Hi guys, this is AS Chemistry, Organic Chemistry, and we are doing carboxylic acid and esters. Question 7. So, three acids have been given to us, S, T, and U, and it says give the structural formula of the organic product formed in each of the following reactions. T reacting with an excess of sodium. So, if we look at the structure of T, we can see that it has two COH groups present and an OH group present. So, sodium will displace hydrogen in the COOH and OH groups because addition of sodium is a test for the presence of the OH groups, whether it is part of an alcohol or a carboxylic acid. So T contains three OH groups present. Two of them belong to a carboxylic group, COOH, and one of them belongs to an alcohol group, OH. So all three will be replaced or rather displaced by sodium. So the product would be Na positive, OOC negative. Then we would have CH bonded to O negative, Na positive, which would be bonded to CH2, which would be bonded to COO minus Na plus. So in this way, we have substitution of three hydrogen atoms by three sodium ions. U reacting with an excess of Na2CO3. So in the structure of U, we can see that there are two carboxylic groups present and two OH groups present. Sodium carbonate would react with the carboxylic group and not with the OH group. So it would form salts with the carboxylic groups. So the product would be Na positive, OOC. Then we would have CHOH and again CHOH, and then we would have COO minus and Na plus. The two OH groups will not react with sodium carbonate, but the two carboxyl groups will react with sodium carbonate, producing sodium salts of the carboxylic acids. Question 8. Compound Q is a viscous liquid which is very soluble in water. The MR of Q is 90. Three possible structures for Q are shown below. So there are three structures R, S, and T. R contains an alcohol group and a carboxyl group. S contains an alcohol group and an ester group. And T contains an ester group and an alcohol group as well. When 0.002 moles of Q is reacted with an excess of solid sodium carbonate, 24 cm cube of carbon dioxide measured at room temperature and pressure is produced. Calculate the amount in moles of carbon dioxide produced in this reaction. So 1 mole of any gas occupies a volume of 24,000 cm cube. So 1 mole occupies a volume of 24,000 cm cube. How many moles would be occupying a volume of 24 cm cube? So this would be 24 divided by 24,000, which would give us a mole value of 0.001 moles. Hence, calculate the amount in moles of carbon dioxide produced by 1 mole of Q. So the question started off with when 0.002 moles of Q reacts. So 0.002 moles of Q produces 0.001 mole of CO2, and therefore 1 mole of Q will produce how much moles of CO2. So the reaction would be okay, not the reaction, it would be here we would just calculate. So it would be 1 over 0.002 into 0.001, which becomes 0.001 upon 0.002, which is equal to 0.5 moles. The reaction stated is with sodium carbonate, so we don't need to write the reaction here. Just calculate the moles of carbon dioxide that will be produced when 0.001 moles of CO2 are produced from 0.02. So 1 mole of Q will produce how much? That would be half, because the molar ratio is 1:2. So 1 mole of Q produces half a mole of carbon dioxide. When 0.002 moles of Q is reacted with an excess of metallic sodium, 48 cm cube of hydrogen measured at room temperature and pressure is produced. Calculate the amount in moles of hydrogen molecules produced in this reaction. So amount in moles. So we need to calculate the moles of hydrogen. So 1 mole occupies a volume of 24,000 cm cube. So how many moles would occupy a volume of 48 cm cube of hydrogen? So this would be 48 upon 24,000. So this gives us a mole value of 0.002 moles. Hence, calculate the amount in moles of hydrogen molecules produced by 1 mole of Q. So, 0.002 moles of Q produces 0.002 moles of hydrogen. So, the molar ratio is 1:1. Therefore, 1 mole of Q will be producing 1 mole of hydrogen molecules. Since the molar ratio is 1:1, the mole value of Q will be equal to the mole value of hydrogen gas produced. Use your answers to B and C. That means the volume of carbon dioxide giving us moles of carbon dioxide and the volume of hydrogen giving us moles of hydrogen with respect to 0.002 moles of Q being used. To deduce which structure R, S, or T corresponds to the structure of Q, and write balanced equations for the reactions that occurred. So according to the calculations performed, if we add sodium carbonate, we have half a mole of CO2 gas liberated, which means there should be 1 mole of COOH group that is present. So COOH group is present in R and not in S and not in T. So it should be R. And when we add sodium, so there should be two OH groups present, because 1 mole of sodium metal produces 1 mole of hydrogen gas. So two hydrogen atoms are equal to 1 mole of 1 molecule of hydrogen. So there should be two OH groups that should give off hydrogen on addition of sodium. So we have one OH group in R and one COOH group in R, both of which will react with sodium, producing 1 mole of hydrogen gas per mole of sodium. So R is the correct compound Q. So identity of Q is compound R. Equation for the reaction with sodium carbonate, so it would be CH2OH, CH2COOH reacting with Na2CO3. So we would need 2 moles of this compound. This would produce 2 moles of OH, CH2, CH2, COO minus, Na plus CO2 plus H2O. So this is the reaction of R with sodium carbonate, and with sodium metal we would have 1 more of this compound HOCH2 CH2COOH reacting with 2 moles of sodium metal producing Na positive, OO, actually Na positive and OH was there, so O negative. O negative, CH2, CH2, C double O minus, Na plus hydrogen gas. Question 9. A series of reactions based on propanoic acid is shown. So, propanoic acid reacts with calcium carbonate to produce three products. In reaction 1, it is converted into propane-1-ol. In reaction 2, propane-1-ol is converted back into propanoic acid. And in reaction 3, we have propanol reacting with ethanoic acid to produce an ester propyl ethanoate. So write an equation for 1 using square brackets H to represent the reducing agent. So we would have CH3, CH2, COOH undergoing reduction to produce CH3, CH2, CH2OH, and the other oxygen would form water. So in total, we need 4 atoms of hydrogen to form the products. What type of a reaction is reaction 2? Reaction 2 is conversion from a primary alcohol to a carboxylic acid, so it is oxidation. Suggest a suitable reagent and conditions for reaction 2. So oxidation of an alcohol into a carboxylic acid would require acidified K2Cr2O7 plus heat under reflux to be carried out. Write an equation for the reaction of propanoic acid with calcium carbonate. So calcium has a +2 charge, so 2 moles of propanoic acid would react with calcium carbonate. So 2 moles of CH3, CH2, COOH reacting with CaCO3 producing CH3, CH2, COO minus twice and Ca2 positive. This would be the salt produced. Then we would have liberation of carbon dioxide gas and production of a mole of water. Suggest a suitable reagent conditions for reaction 3. So reaction 3 is reaction with ethanoic acid to form the ester. So reagent would be ethanoic acid, or we can write CH3COOH, and the conditions would require an acid catalyst. So H2SO4 would be used, and it would require heating under reflux to form the ester propyl ethanoate. Identify the other product of reaction 3. So we have an ester being formed and we have water. H2O would be formed along with the ester. Question 10. Compound F is an ester with the molecular formula C4H8O2. F is one of 4 isomers S, T, U, and V that are all esters. In the boxes below, the structural formula of S is given. Draw the structural formula of the other 3 isomers of F that are esters. So the structure given has an alcohol with a methyl group as a substitute group and a single carbon carboxylic acid. So we can have the same alcohol but all three carbon atoms in a straight chain. So we can have HCO2, CH2, CH2, CH3 as our second isomer of F. Then we can have one of the carbon atoms in place of alcohol, it moves to the carboxylic side of the ester. So we can have CH3, CO2, CH2, CH3, and in a similar way, another carbon atom moves towards the carboxylic side of the ester. So CH3, CH2, CO2, and then CH3. So these are the three other possible structures of F other than the structure shown as S. When the ester F is hydrolyzed and alcohol G is produced, what reagent can be used to hydrolyze an ester to an alcohol? So we can use water plus acid. Acid could be HCl or H2SO4. And since we're talking about only alcohol being produced and not a carboxylic acid, we can also carry out alkaline hydrolysis. So NaOH aqueous can also be used. What other type of organic compound is produced at the same time? So if we are using water and an acid, we end up with a carboxylic acid. And if we are going to use NaOH, we are going to end up with a sodium salt of a carboxylic acid. So whichever reagent we use, we have a relative other product to the alcohol produced that we need to state. If it's acidic conditions, we end up with a carboxylic acid. If it's alkaline conditions, we end up with a sodium salt of that same carboxylic acid. Question 11. Although there are many different types of food eaten around the world, animal fats and or vegetable oils are commonly used in cooking. Animal fats and vegetable oils are usually glyceryl esters, that is esters of glycerol, propane 123 triol, and its structure is given. Many animal fats contain esters of stearic acid, and the acid is given. It has 18 carbon atoms present. Vegetable oils often contain esters of oleic acid, and its structure is given as well. Draw the structural formula of the glyceryl ester formed when one molecule of glycerol is completely esterified with stearic acid. So we have 3 moles of OH groups in glycerol, and we have one COOH group in stearic acid. So 3 stearic acids will react with 1 mole of glycerol. So the product would be CH3, CH2, 16, COO, and CH2. This would be connected to CH, which would be connected to CH2 again. So, and we would have the same part of the molecule as shown in attached to the first CH2 group of glycerol on the second and the third position. So CH3, CH2 16, and COO, and again CH3, CH2 16, and COO. So this is the ester that is formed when 3 moles of stearic acid react with 1 mole of glycerol. The reagents would what reagents would you use in a school or college lab to obtain a small sample of oleic acid from glyceryl ester present in vegetable oil? So we need to hydrolyze the ester, so we would use HCl aqueous or H2SO4 aqueous plus heat to carry out the reaction in which we have to obtain a small sample of oleic acid from the glyceryl ester present in vegetable oil. So we are basically carrying out hydrolysis of the ester. Question 12. A student reacted together an alcohol and a carboxylic acid under appropriate conditions to produce an ester, a sweet smelling organic liquid Q with the empirical formula C2H4O was produced. The MR of Q was found by experiment to be 87.5. What is the molecular formula of Q? So, in order to calculate the molecular formula of Q, we need to find out the empirical formula mass. So, that would be 12 to the 24 plus 4 plus 16. So, this is equal to 24, 30, 44. So, this is 44. And then when we divide 87.5 by 44, we end up with a value of 2. So, C2H4O multiplied by 2 gives us a formula of C4H8O2. So the molecular formula of Q is C4H8O2. In the boxes below, draw the structural formula of four isomers with the formula that are esters. So C4H8O2. So we can start off with a single carbon containing carboxylic acid. So H, C double bond O, single bond O, and then we've got three carbons. So CH2, CH2, CH3. Then we can have the same carboxylic acid, but we can introduce substitution in the branching in the alcohol. So we can have CH, CH3, and CH3. Next, we can shift one of the carbon atoms towards the carboxylic side of the ester. So CH3, C double bond O, single bond O, CH2 and CH3. And we can repeat the same process by shifting another carbon to the carboxylic side of the ester. So we have CH3, CH2, C double bond O, single bond O, and we're left with one carbon atom. So CH3. Therefore, all four of these esters formed have the molecular formula C4H8O2 and are isomers of one another.